October the 3rd, 2025. On the rust-red plains of Jezero Crater, Perseverance lifted its gaze and caught something drifting through the Martian sky. The pictures were not beautiful in the way people imagine astronomy to be. No crisp fins or shimmering tail, just a cluster of faint frames where the light smudged differently than it should. An astrophotographer named Simeon Schmaus took 20 of those rover images and layered them, patiently aligning noise against noise until signal appeared. There it was at last, a pale flaw, a whisper of brightness, precisely where the interstellar wanderer was predicted to pass. The internet exhaled in unison. Threads blossomed, arguments sharpened, careful analyses appeared next to wild speculation, and yet under all the chatter ran a soft, uneasy undertone. Why did a day of promised clarity arrive wrapped in static? Because that same day, exactly when eyes across two worlds should have been wide open, 15,000 NASA employees were told to go home. The Mars Reconnaissance Orbiter, with its high-resolution imaging science experiment, a camera that can pick out objects on Mars smaller than a parked vehicle, was perfectly placed for the picture of a lifetime. ESA's Mars Express was awake. ExoMars, Trace Gas Orbiter, was listening. Instruments were ready. Geometries aligned. But the stream of images that should have poured forth never arrived. Where were the portraits of a visitor between the planets? What followed grew stranger still. Months earlier, in August, remote viewers, yes, the controversial kind who sit with blind coordinates and let impressions spool out, had described technology inside this traveller. Not a shining craft, not a city-sized engine, but something humble in shape and audacious in intent, a device the size of a thumb drive, deliberately set within ancient ice and stone, pulsing in patterns like a beacon trapped in amber. They said this before telescopes began to whisper of chemical combinations that did not quite fit the textbooks. Tonight's story unfolds in two gentle arcs. First, everything new and unsettling about the object we will call 3I Atlas, then the week's quieter notes from space. If you enjoy drifting through mysteries like this as you fall asleep, you are warmly invited to subscribe to Space Historian and tap like. It truly helps our small observatory keep its vigil without breaking the quiet. 48 hours ago, a Twitter post rippled outward like a pebble touching the surface of a still lake. A user calling themselves UFO Mania shared an image and a line that jolted the astronomy crowd. The nearest of the 3I Atlas passes was not a comet at all, but a cylinder. Clean, elongated, purposeful. The coordinates matched the flyby window. The timing matched the ephemerides, and the silence from official accounts somehow matched as well. It is tempting to dismiss such things as internet mirage, but this was not a backyard blur with convenient stars smeared into authenticity. The post arrived amid an unusual tenderness in the data stream. The very day 3I Atlas skimmed past Mars, when every eye we had in that celestial neighborhood should have been brimming with images, nothing official came out. The high-resolution imaging science experiment aboard MRO, capable of outclassing old Hubble views by a factor of 30 for Martian targets, was perfectly placed. The European orbiters were aligned. The geometry was exquisite, but from those machines, for the public, the sky went quiet, not empty. Quiet. Into that hush stepped an account calling itself 3I Atlas Anomaly. It did not speak the breathless dialect of conspiracy. It spoke in footnotes and phase angles. 10 points, each anchored by a named instrument or a published release. James Webb's note of a carbon dioxide-rich coma, Swift's detection of water and hydroxyl emission, a puzzling polarimetric dip, a negative 2.77% at a Sun Object Observer phase angle near 7 degrees. A peculiar combination not seen together in the catalogues of ordinary comets and asteroids. These weren't the hand-waving generalities you can neither prove nor disprove. They were real measurements with provenance. The thread didn't shout, it clicked. Then a voice from outside the usual astrophysics chorus joined in. A plasma phenomena researcher with a newsroom pedigree, someone who once carried a BBC press badge, posted that a respected cosmologist, Stephen Burns, had privately concluded the object was intelligent, cloaked in dusty plasma, and already conversing. With us, with other worlds. Consciousness, communicating. Even the skeptics paused over that sentence. It did not live in a fringe forum. It sat in public, tied to a journalist's name and work history like a business card set on a table. One detail in her post curled like a leaf in the heat. The object had moved too close to the sun for us to watch. For months it would be lost in glare. Not until December would Earth-bound telescopes catch it again. 3 months is a long time in a story that flexes. If a trajectory bends while the sun is between us, the change happens in darkness. We would not know until it stepped back into the evening sky. Another thread came from a different direction altogether. Not the comedian, but a journalist and investigator in the UFO world posted a line that read like a telegram from an older age. My source has gone quiet. NASA is closing its doors. Congress is on recess. If 3I Atlas activates, ancient texts say, the sky will blaze with knowing light and the world will forget its reflection. They called the warning prophecy. Agencies call it protocol. He called it imminent. Hashtags about Vatican archives and harbingers trailed his post the way little sparks trail a meteor. Technical graphs and occult whispers coexisted uncomfortably on the same screen. Through it all, one fact persisted with the stubbornness of a ticking clock. In the 48 hours after the flyby, not a single publicly released image arrived from any of the orbiters who were watching. Not from NASA, not from ESA, not from Tianwen-1 or the UAE's Hope orbiter. What we had instead was Simeon's stacked Perseverance frames, 20 images from Mastcam Z, sifted together until a thin smudge could be discerned near Corona Borealis, close to where the cometary path said it should be. That was, apparently, our closest look at an interstellar visitor from a fleet of spacecraft that can count boulders on Mars. A grey smudge. Unless, of course, something sharper was captured and simply not shared. The 3I Atlas anomaly account continued to post. The updates remained restrained in tone and firm in content. Unexpected brightening, they wrote, a light curve swelling faster than models at this distance predict. That could imply more abundant volatiles, or a mechanism more efficient than standard sublimation. As ground-based observatories lose the object to solar conjunction, they added, ESA may repurpose Mars orbiters to keep watch near the 3rd of October, pass at roughly 30 million kilometers. Each item on its own was unremarkable. Together they traced the outline of a thing that refused to behave, and then came the shape. Independent amateurs, working with unglamorous stacks of suboptimal data, processed their frames carefully, cleaning for stars and seeing, equalizing the background, pulling at the edges of contrast the way a conservator lifts soot from a fresco. What remained was not the soft, airy puff of a comet with a healthy coma. It was smooth. It was elongated. It was almost geometric. The word that kept recurring was cylindrical, just as that early viral post had claimed. Skeptics were right to caution. Motion can stretch an object. Algorithms can manufacture line. Comets scatter light in ways that trick the eye. All true. And yet, geometry also happens at the level of structure. We learned that lesson with the first visitor we named from another star. Oumuamua, pancake in some reconstructions, cigar in others, never a simple sphere. Unfamiliar forms are not, by themselves, arguments for artifice, but they are reasons to pay attention, especially when the officials whose pictures we need keep their mouths closed. When NASA did speak, it said the thing that matters most to anxious listeners. 3I Atlas is not dangerous. Its path will keep it hundreds of millions of kilometers from home. It will brush past the sun at the end of October and slide back into the deep. All of that sounds right. All of it is probably right. None of it addresses the question the public is actually asking. What is it? And why, on the day designed for clarity, did 15,000 of the agency's civil servants find themselves standing on their doorsteps with nothing to do? In August, 2 months before the Mars pass, before the furloughs, before the social networks learned the object's name, an experienced remote viewer sat down with a set of numbers and a blank mind. Her name is Birdie Dworsky. For nearly 3 decades, she has practiced controlled remote viewing at a professional level. She once served as a vice president at the Farsight Institute. She holds a master's degree in digital forensics. It is not the resume of a person angling for clicks with neon claims. A friend handed her coordinates with no context because that is how proper blind targets are done. The viewer receives no photographs, no headlines, not even a hint of category, object, event, place. Birdie relaxed into protocol and let impressions surface. Something was moving in space, something old, so old it felt like the age of its own materials had sunk into them like a scent. It read, at first, like a natural object. Rock and ice partnered against the vacuum, behaving as a comet behaves if you have never been taught the word comet. Then she noticed a fingerprint where there should have been none. A pattern within random noise. At a deeper pass, she found the shape of it. A small object buried within the larger one, about the size of the little sticks we carry in our pockets to hold libraries of bits. Not on the surface, she emphasized. Inside. Someone had bored into the ice rock body and tucked the device away as neatly as a message sealed in the hollow of a tree. She did not call it alien, she called it deliberate. An archive with teeth, a message in a bottle that can do more than speak. Pause on that idea and you realize it is not foreign to us. We launched the Voyagers with their gold records, hoping a future listener with a patient ear would find meaning in our songs and diagrams. We bolt plaques to the sides of ships. We bury time capsules. The leap is not in the intention, it is in the carrier. We had thought only of sending our messages in metal. The idea of using a natural traveller as the bottle is elegantly ruthless. Ice doesn't corrode. Only after Birdie had finished her session did her friend reveal the target. 3I Atlas, a visitor whose formal announcement had barely begun to spread outside specialist circles. Birdie went back twice more, each time narrowing her attention. She came away with the same sensation and one new element. The device was not silent. It broadcast impulses. Present tense. Not a recording from some remote epoch, but a hand tapping now. During a podcast conversation, the host mentioned that Avi Loeb had floated an odd correlation. The path of 3I Atlas appeared to originate from the general region of sky associated with the 1977 WOW signal. Birdie didn't hesitate. That's interesting, she said. It could very well be the same thing. Remote viewing unsettles people because it is not repeatable in the way laboratory tools are repeatable. The controls are human. The instrument is a mind. You cannot place it on a bench and recall results at will. That makes skeptics bristle and believers nod, and the rest of us shuffle. unsure where to stand. But Birdie's account would not be alone for long. Other groups turned to the same blind target and, uncoordinated, came back with overlapping shapes, technology, deliberate placement, pulses, non-human involvement. One team reported perceiving humanoid forms in association with the object. Another said there were markings, graffiti almost, as though someone had signed their work with a flourish and a joke. A few described the whole thing as masked, using some technique to shroud itself from full view. One set of viewers wrote about special access and extraction points, another about timelines and windows that open and close like gills. Some of the reports wandered into darker terrain, crop circles linked by a logic we have not solved, spherical craft moving like thought, a kind of hybrid warfare that does not leave the usual fingerprints. Phrases like invisible war and brain scanning technologies cropped up more than once. It sounded melodramatic at first, until you remembered how easy it is to push whole populations into panic or apathy with nothing but words, a technique we already practice on ourselves. Does any of this prove 3i Atlas is more than a comet? No. Anecdote cannot take the witness stand for measurement. Remote viewing lives in the region where psychology and mystery overlap. It is not a replacement for spectroscopy, imaging, or gravimetry. But when different minds, kept blind to each other, trace similar outlines, you at least learn which questions to ask. Imagine for a moment that Birdie's core description were true, a small device sealed inside an ancient travelling body. What would we expect from afar? Behaviour that paints like a comet, dust and ice warmed into gas, tails shaped by radiation and wind. Look closer though, and you might find stubborn elements unaccounted for. Chemistry that leans the wrong way. Materials that feel manufactured when you look at their lattice. The mass could come up heavy for the visible size, as if a dense heart refuses to sublimate. And if it is designed to be found, you might catch a rhythm in the noise, a pulse coded to be seen by instruments when the geometry is kind. Birdie's sessions happened before the most intriguing anomalies had databases to live in. Before the silence. Before the faint cylindrical rumours. Before the brightening curve steepened and then steepened again. Now, with perihelion approaching like a confession extracted by heat, the timeline compresses. If there is truly a thumb-sized device at the core, late October is when the shell is stressed most, when outgassing is strongest, when hidden things either carry on hiding or slip, and there is that awful coincidence to step around. The day the Mars shots should have sung, NASA's workforce thinned to a skeleton. A few essential teams kept the machines healthy. The rest went home. Somewhere in that quiet you can hear a question that remote viewers have been asking since August. What did they see that we are not seeing? The 3rd of October was meant to be a simple kind of triumph, a cool exercise in celestial geometry. Point exquisitely engineered machines at a once-in-a-civilization object. Blink, collect. The Mars Reconnaissance Orbiter was where it needed to be. HiRISE was primed to catch detail 30 times finer than Hubble manages for similar tasks. European hardware was aligned and alert. And then, like someone dimming a theatre house light at the exact wrong moment, 83% of NASA's civil servants were furloughed. 15,000 people. Gone, for now, from their desks, during a week the agency would spend decades trying to recreate. The public explanation made bureaucratic sense. A government shutdown over budgets. Unfortunate timing, they called it. Those two words did a lot of heavy lifting for a sequence of events that felt like a magic trick performed in broad daylight. 3i Atlas was discovered in July. The Martian geometry was calculated and public. Schedules were written. Observers knew it would be the best chance, perhaps the only chance, to take unambiguous pictures before the sun swallowed the view. Everybody knew. Yet in the last days before the pass, shutters closed at the very institution most capable of showing us what we long to see. The machines themselves did not stop. Perseverance continued to upload raw frames to the same feeds it always uses. Mars Reconnaissance Orbiter kept circling, the way a lighthouse keeps turning even when no one stands at the console. Data was being captured, but very little was being let out where anyone could look at it. A YouTuber with a Solar Watchers kit, posting under the name Dobsonian Power, shared an image on the 3rd with a caption that felt like a hand pressed to a window. What on earth is it? The photograph showed a dark, angled something nested in the place the calculations put 3i Atlas. If an amateur could catch that echo, people asked, what were the professionals seeing? NASA said nothing. ESA said nothing. The only tangible sign that the celestial appointment had been kept came from the same astrophotographer who had layered Perseverance's faint images into coherence. Simeon again, this time with his careful stack and his quiet description of a smudge. When the White House press room filled for a briefing about the shutdown, the conversation stayed earthbound until a reporter raised a hand and asked whether the president had been briefed on 3i Atlas. For a moment, the room remembered how to hold its breath. The Deputy Chief of Staff for Policy, Stephen Miller, measured his reply and stepped past it. In that non-answer, a line had been crossed. The question lived, on camera, in the official record. It had left the warm pools of social media and stepped into fluorescent light. Meanwhile, Avi was making the rounds on news networks, Newsmax, CBS, podcasts, anyone who would listen. He laid out the anomalies with mathematical precision. He spoke in numbers that felt like pebbles dropped one by one into a still pond. A path almost flush with the ecliptic, something that should happen only 2 times in 1,000. Arrival timed so neatly for planetary meetups that the odds shrank to 5 in 100,000. 7 traits, he said, that set 3i Atlas apart from every wanderer we have ever tracked. And he kept circling back to a single simple demand. Show us the Mars Orbiter data. A single high-rise frame could bound the core's size. A short sequence could reveal shape, structure, seams, edges if any exist. Those pictures would answer the quiet question that haunts the rest, but the pictures did not come. On a calm conversation with Brian Keating, he mentioned that Representative Tim Burchett, a sitting member of the House Committee on Oversight and Accountability, had joined him on a Newsmax segment to talk about the object and about the troubling quiet around it. A congressman discussing an interstellar visitor on national television is not fringe. It is the mainstream clearing its throat. Yet the silence from NASA persisted. Across the Atlantic, the European Space Agency broke cover just far enough to confirm that Mars Express and the ExoMars Trace Gas Orbiter had indeed watched 3i Atlas during the window from the 1st to the 7th of October. They listed instruments as if reading a manifest. High-resolution stereo camera, Cassius, several spectrometers, and promised analysis in the coming weeks. Results when ready. No teaser images, no early plots, no spark of shared wonder, just a careful, dry acknowledgement that the cameras had opened and then again, silence. China's Tianwen-1 said nothing. The UAE's Hope Orbiter said nothing. Every machine at Mars had turned an eye, and every agency on Earth kept its mouth closed. You do not need a taste for conspiracies to feel the strangeness. You only have to remember 2I/Borisov. When that interstellar comet arrived in 2019, pictures poured out. Scientists were delighted. Press offices hummed. The community threw an honest, nerdy celebration. It behaved like a comet, so it was studied like a comet, and the public got to come along for the ride. 3i Atlas gets a drawn curtain. Perhaps the difference is simple. Borisov ticked all the expected boxes. It was interstellar, yes, but normal in its bones. This new traveller keeps stepping outside the lines. It raises the kinds of questions that make institutions cautious. And so, as it slipped behind the sun toward perihelion, the one stretch of the sky where Earth's observatories cannot follow, the hush deepened. Amateurs posted their last stacks. Papers appeared with language tuned to the cautious key of journals. Precise, professional, deliberately non-speculative. 15,000 furloughed NASA employees waited to be called back, and you could imagine more than a few wondering what their essential colleagues had seen in those orbiter frames that the rest of us had not. There is an old habit in science called Occam's razor. When explanations compete, choose the one that requires the fewest leaps. One oddity can be waved away. Two make you frown. Stack 7 unlikely features together, and the simplest path may be the one that says the situation is not simple at all. First, the matter of mass. Early brightness to size estimates suggested something in the 10 to 20 kilometre range if all that light were just sunlight bouncing off a surface. For comparison, Oumuamua was somewhere around 100 metres across, 2I/Borisov under a kilometre. 3I Atlas, on paper, looked orders of magnitude bigger than any interstellar visitor we've seen. The statistics of discovery don't like that. Our surveys are more likely to snag small travellers than giants. One estimate put the chance at roughly 1 in 10,000. Then came the astrometry. More than 4,000 measurements from hundreds of observatories across months. When the track was compared to what pure gravity would do, the non-gravitational shove, jets of gas and dust acting like tiny thrusters, was barely measurable. That is remarkable for something shedding on the order of 150 kilograms per second. To shrug off that constant push, the nucleus must be heavy, enormously so. Calculations pointed to tens of billions of tons, a body 5 kilometers or more across, not just larger than the last 2 interstellar visitors, but perhaps 1 million times more massive than Oumuamua. Grain of sand, meet boulder. Second, the sun would glow. Hubble's best look on the 21st of July 2025 showed scattered light extending farther toward the sun than away from it, farther even than sideways, by a factor that raised eyebrows. Comet dust normally sweeps away from the sun under radiation pressure. That is Comet's 101. Here, the extension along the solar direction was measured at about 10 times the perpendicular reach, and because the view was nearly edge-on, the true geometry may be even more extreme. A careful paper suggested a mechanism with fragments of ice sublimating at different rates depending on where they lift off. A fine piece of physics that hangs together but requires a choreography we have never caught anywhere else. A unique solution for an object already rich in uniquely awkward details. Third, the fingerprint of industry. Late August into early September, the VLT in Chile pulled spectra and found something that made even seasoned observers go quiet. Plenty of nickel atoms in the gas. Almost no iron. In nature, nickel and iron are forged in supernovae together, paired like twins. Throughout our measurements of comets, solar system and interstellar alike, their ratio holds steady. Borisov held to it. Our own comets hold to it. 3I Atlas did not. Nickel rose sharply as it neared the sun, roughly following a ninth power law, with iron absent or whisper faint. Under normal conditions at that distance, the mineral grains that contain such metals do not just vaporize. Papers tiptoed through possible chemistry, but the unease showed in their phrasing. It looks, some admitted, like separation, refinement. Fourth, polarization that refuses to fit. Scatter sunlight off particles and you polarize it. The angle and strength tell you about size, texture, composition. We have built palettes of expected behavior for comets over decades. 3I Atlas painted outside the palette. Roughly 77% at a phase angle near 7 degrees, with an inversion angle around 17 degrees. Nothing in the Comet Asteroid Catalogue matches that combination. The closest echoes come from the cold fringes, trans-Neptunian objects, and a centaur named Pholus, bodies iced and altered in ways far from the norm. One team's careful conclusion was that 3I Atlas may represent a distinct class. In the language of journals, distinct class means, for now, uncatalogued. Fifth, the plane itself. The solar system is a thin sheet of orbits, the ecliptic. Visitors from between the stars are expected to arrive from all directions. The chance that one's path lies within 5 degrees of our plane is about 2 in 1,000. 3I Atlas did that, and it came retrograde against the planetary flow. If you were intent on skimming past multiple worlds with minimal steering, you could hardly draw a better track. Sixth, the appointments it keeps. By chance, it will come within modest astronomical distances of 3 planets. Venus about 0.65 AU, Mars tinier still at 0.19 AU, Jupiter near 0.36 AU. The combined timing that enables those passes from a random arrival is on the order of 1 in 20,000. It reads less like fluke and more like itinerary. Seventh, the old margin note. In 1977, the Big Ear telescope heard a narrowband signal from Sagittarius that lasted 72 seconds. Jerry Ehman looked at the printout and scrawled, "Wow." When teams backpropagated the path of 3I Atlas through the galaxy, folding in its speed and direction, they arrived at a position in that year within roughly 9 degrees of the WOW signal's origin. Another long shot, about 6 in 1,000. 7 long shots do not automatically add up to a conclusion, but they do make a straight shrug hard to defend. Now, while you are listening, 3I Atlas is hidden in the sun's glare, sailing toward a place where heat and gravity refuse to let anything pretend. Perihelion is not just a word, it is a kiln. For this object, the moment falls on the 29th of October 2025, at about 1.44 astronomical units, close to Mars's neighbourhood, close enough that sunlight stops being a gentle lamp and becomes an engine. You can think of an open blast furnace if it helps, though the reality makes even metaphors blush. Avi has a line that lingers. High-stress environments elicit confessions. Interrogators know it. Physics does too. Warm ice behaves like ice. Warm rock behaves like rock. Warm camouflage, if camouflage exists, can slip. 2 broad futures open at the kiln's mouth. In the first, 3I Atlas is exactly what a cautious mind expects. A comet, if a peculiar one. The rising temperature turns carbon dioxide, solid, into gas. Water is dragged into vapor. Dust lifts in plumes. Brightness jumps, perhaps tenfold or more. A proper tail forms, not this curious sunward smear, but the classic streamer pressed away by radiation pressure. The body may even crack under stress, shedding pieces in a sparkling unmaking. We have watched such dramas before. If this is the scene, we will learn a great deal from the fragments and the spectrum. It will be a quiet triumph, even if our visitor dissolves while we watch. In the second, the anomalies are not coincidences. They are tells. The nickel without iron hints at manufacture. The retrograde path along the ecliptic hints at purpose. The WOW lineage hint suggests a message with a long memory. In that case, perihelion is not a stress test, it is a switch. If you meant to send a probe across gulfs measured in billions of years, you would keep it simple and protected. Ice is abundant. Ice shields. Ice makes your messenger look like a harmless pebble, but once it reaches the inner system, it needs power. There is only one wall plug here, the star. One can imagine a solar oberth maneuver, an old elegant trick where you dip close, burn at the moment of highest speed, and change your course more efficiently than anywhere else. If you wanted to hide a deflection, you would do it when Earth cannot see you. Or you might let smaller instruments fly, tiny craft peeling off to fall inward toward worlds with a minimum of fuss. With the current alignment, those trajectories are cheap in fuel and rich in encounters. He said it carefully on air and in print. If 3i Atlas reappears with a path altered toward Earth, markets may not take the news with grace. That is not panic-mongering. It is an honest sketch of how fragile our sense of certainty can be. But none of us can check yet. Between now and early December, we are blind from the ground. The sun sits between us and the answer. One consolation, ESA planned a glance. Between the 2nd and the 25th of November, JUICE, the Jupiter Icy Moons Explorer, en route to a different set of mysteries, will swivel sensors to catch 3i Atlas just after its swing by the sun. JUICE was built to sniff out the fingerprints of oceans beneath ice, to map fractured crusts and thin atmospheres. Even so, its cameras and spectrometers can watch a comet. From its current vantage, it sees angles we cannot. If a great normal coma blossoms, JUICE will register it. If the body breaks, it will sketch the debris. If something stranger occurs, steering, shedding, signals, those instruments will notice. The data will not tumble down instantly. Distances and bit rates make patience part of the craft. But by late November into early December, we should have a first look. Around the same time, the object will clear the sun from Earth's perspective and slide back into our sky. On the 19th of December, it makes its nearest pass to our planet, still a long way off at roughly 1.8 AU, no danger, but close enough for every major observatory to lock on and measure the track with exquisite care. If the orbit remains what gravity alone predicts, we exhale. Strange but natural, a guest who came and went. If the numbers stray in ways that outgassing and sunlight cannot justify, then the answer is not an answer so much as a revision of our place. October 29th is when the confession, if there is one, is spoken. December is when we finally hear it. Sometimes in stories like this, a delay is the plot. While the laboratories sharpen their pencils and the agencies keep their lips pressed thin, the rest of the world does what it always does. It tells stories about the sky. The fire started in the United States, where such sparks often catch. TikTok clips, some real, many edited, all compelling at a glance, multiplied into millions of views. Reddit threads bristled with graphs and guesswork. X, as Twitter now calls itself, filled with a mix of careful amateurs posting genuine observations and influencers spinning wilder tales to feed the algorithm. Then the current turned. In India, the narrative mutated as it poured through WhatsApp. Forwards in Hindi painted an alien ship hiding in plain sight. Urgent narrations insisted the object was changing course. Screenshots of fabricated headlines designed to frighten travelled faster than any correction. One forward claimed governments were already negotiating with whoever or whatever guided 3i Atlas. Another implied quiet military movements. A third presented a doctored, classified NASA image, a geometric skeleton where a comet should be. None of it true, all of it sticky. Hindi language channels on YouTube bloomed. Some tried earnestly to explain what an interstellar object is and isn't. Others stitched authentic facts to ancient astronaut myths and prophecies until the seam vanished. education and entertainment blurred into a single, breathless category. In Brazil, Telegram groups and Facebook pages lit up. Communities that had spent years puzzling over lights above the Amazon swung their attention to a target with coordinates and ephemerides. A real object, interstellar, called puzzling by scientists themselves. That is jet fuel for believers. Brazil's conspiracy ecosystem is, by long practice, uniquely vibrant. In Brazil, the story learned to wear every mask at once. Indigenous myth threaded through Catholic mysticism and modern UFO lore until the tapestry defied neat labels. 3i Atlas became a mirror that returned whatever a watcher brought to it. Omen, arc, warning bell, test. Facebook groups swelled overnight. Live streams went on and on, hosts reading real papers sentence by sentence, then pivoting, often mid-breath, into claims the authors had never made. The comment sections felt like nighttime bonfires. Fear and wonder held out to the glow, thousands of voices telling each other what the sky meant. In the United Kingdom, where crop circles and methodical UFO investigations share the same hedgerows, the response mixed skepticism with a distinctly British curiosity. Tabloids threaded the needle with headlines that promised spectacle, while keeping one toe in plausible deniability. Massive comet might be alien tech, scientists say. The scientists were, more often than not, Avi Loeb quoted, with the context sanded away, but the headlines did their work. Russia, predictably, viewed the whole affair through a geopolitical lens. State television mentioned the object only in passing, careful to highlight American uncertainty each time. Some voices suggested Western capitals needed a crisis to justify budgets. Others hinted that Washington knew much more and was keeping it close, perhaps because secret programs had already made contact. Russian-language forums lit up with impressively technical threads. Orbital elements, polarimetry, gas production rates, threaded through with talk of black projects, salvaged craft, and conspiracies stretching back to the Soviet era. Then came the Mikio Kaku flare-up. A screenshot began to circulate showing the physicist on television, with a caption claiming he had said 3i Atlas was conducting reconnaissance, possibly with hostile intent. The line read, "It might be an alien probe sent to Earth." The image itself was genuine. The context was counterfeit. Fact-checkers traced it to a Nation News interview from the 20th of February 2025, months before 3i Atlas even had a name, and on an entirely different topic, almost certainly asteroid risk. Someone had lifted the frame, pasted on new text, and set it adrift. It hardly mattered. The post racked up nearly 300,000 views before platforms began labeling it, and by then copies of copies had seeded across timelines where corrections rarely grow. The account that posted it, Lord Bebo, never issued a correction. The harm was done. A respected scientist had been drafted without consent into a claim he never made. NASA tried a steadying hand. On the 30th of September, its official solar system account posted, "Comet 3i Atlas poses no threat to Earth. It will remain hundreds of millions of kilometers away." This is a natural interstellar object, extremely rare and scientifically valuable, but not dangerous. The reply chorus was instant and skeptical. If it's just a comet, why the furloughs? If it isn't dangerous, why the silence? If it's natural, how do you square nickel without iron? NASA did not wade further into the thread. One statement against a global tide. Al Jazeera's fact-check unit, SANAD, published a careful audit. Discovery date the 1st of July 2025 by the Atlas survey confirmed. Closest Earth distance around 270 million kilometers confirmed. Kaku quotes fabricated. Rumors of secret negotiations or military mobilization baseless. It was good journalism. It moved very few hearts. Because while Sanad tracked citations, Avi Loeb was quietly visiting with diplomats. Not a podium at the General Assembly, but side rooms where policy advisors used the word existential without irony. He outlined a black swan scenario: low probability, high impact, deserving preparation precisely because we prefer to wave it away. Taleb built that idea to explain financial crashes. Loeb applied it to visitors between the stars. We assume natural because natural is all we have seen. What do we do the day that assumption snaps? The Harbinger began trending, not in the broad public square, but within communities watching Three-Eye Atlas like weather. The term comes from old texts, messengers in the sky, heralds of judgment or change. Some readers took it literally, grafting end times theology onto telescope anomalies with surprising ease. Others used it as metaphor, a harbinger of a new spacefaring age, of an awakening to a busier universe than we dared imagine. Through this rising chorus, a name resurfaced again and again. Stefan Burns, the cosmologist Moneypenny had flagged. Claims spread that he believed the object exhibited intelligence, that it was conscious, that it had already begun dialogues. Us, Mars, others. No one could locate a single paper, a verified interview, a transcript, just second-hand summaries and ambiguous posts. The rumour endured because it fit the mood, the anomalies, the hush, the sense of an unfolding event we could only glimpse in profile. All of it made that claim feel like a missing puzzle piece, whether or not it actually belonged. Chapter 7. December's Verdict. Early December 2025. Three-Eye Atlas will rise from behind the sun like a diver breaking the surface. Astronomers will pick it up in Virgo, low in the east before dawn, around magnitude 12 or 13, too faint for most backyard telescopes, well within reach of the big mirrors. Everyone will watch the numbers. Orbital mechanics is one of our sharpest tools. Newton, refined by Einstein, lets us predict a position years ahead to within a handful of kilometers. We can model gravitational tugs, sunlight's gentle pressure, even the feathery thrusters of outgassing. When the object reappears, its place on the sky will speak plainly. If it sits where gravity says it should, allowing for the slight drift that gas jets can cause, then we'll have strong reason to believe nothing extraordinary happened while it hid in the glare. It rounded the sun, endured the heat, and continued outward toward the dark. If the position is off, if the track curves in a way radiation and outgassing can't explain, then the literature will need addenda. Objects don't change course without a hand on the tiller. The Vera Rubin Observatory will be pivotal in what comes after. Newly awake, it represents a step change in how we sweep the sky. Past surveys turned up something like 20,000 new asteroids a year. Rubin found over 2,000 in its first 10 hours. 10 hours, 2,000. Once Rubin turns its gaze to interstellar visitors, the trickle becomes a stream. Dozens discovered each year, perhaps. Each one examined with fresh lessons from Three-Eye Atlas. Chemical tells, polarization quirks, trajectories that look more like plans than chance. If this object is a category breaker, Rubin will find its siblings. But December is about more than orbits and future surveys. It is about questions that have hung in the air since July. What did the Mars orbiters actually see? By then the furloughs will be long over. NASA's desks will be full again. The HiRISI images from the 3rd of October will have been ingested, cleaned, measured, argued over, and either ushered toward publication or tucked away. At 29 million kilometers, a 5-kilometer nucleus, if the coma allowed, should show shape. Not crisp detail, but honest morphology. rounded, stretched, irregular. Brightness variations that hint at surface materials. A silhouette we can compare to the gallery of comet nuclei we have already photographed. The fact that nothing has been released raises a question a calendar page cannot dismiss. Space science thrives on being first. That multiple agencies watched and none have shown their close-ups suggests either an unlikely global coordination in restraint or that what was captured needs careful handling before daylight. December will force the matter. Either the images emerge and confirm an eccentric but natural body, or their continued absence becomes an answer of its own. Radio astronomers will be listening as well. The WOW signal link is either coincidence or it is not. If 3I Atlas was anywhere near the 1977 source region, and if it can still speak, December offers a second chance to hear it. Several radio facilities have been quietly tracking, not with press conferences and countdowns, but with patient coordinated watches. Any emission, any periodicity that walks across frequency space in step with the object's motion would be epical. The hydrogen line at 1420 MHz will be watched very closely. That is where WOW lived. That is where a civilization might choose to call across the dark, precisely because hydrogen's line is a universal yardstick. On the 19th of December, the object reaches its closest Earth distance, about 1.8 AU, roughly 270 million kilometers. That is no threat. It is, however, close enough for exquisite measurement. As Earth moves along its orbit, parallax shifts the object's apparent position against background stars. Coordinated observatories, north and south, will track those shifts. Amateurs will contribute too. With enough eyes, with timing locks and careful reductions, we will fix the path with absurd precision. Somewhere in that tapestry, if anything changed during the blackout, we will see the seam. By late December, 3I Atlas will dim again as it heads outward, sliding into Leo and the long arc toward Jupiter's orbit, which it will cross in March 2026. Beyond that, the outer system, the heliopause, interstellar night. One way or another, December will answer enough to change the mood. Perhaps not every question, but enough to tell us whether we just watched the loveliest comet show in a generation or the opening notes of a deeper rewrite. One to rank with the moment we realized Earth does not sit at the center of things. The telescopes are ready. The equations are sharpened. The world is awake. If this kind of calm late-night skykeeping speaks to you, you can quietly subscribe and like Space Historian. It genuinely helps keep the lantern lit while we wait. Chapter 8. The Scientific Impossibilities. Let's walk carefully into the numbers that keep astronomers awake. Not theory casting, not myth, but the measurements that refuse to sit still no matter how often you recompute them. Begin with the WOW signal. The 15th of August 1977. The Big Ear radio telescope at Ohio State turns up a narrowband spike at 1420.4 mHz. The hydrogen line. The calling card frequency for techno signatures. It lasts 72 seconds, the exact time Big Ear's beam takes to drift across a steady source with Earth's rotation. The signal is strong, around 30 times the noise. On the old dot matrix printout, the coded intensity climbs. 1S and 2S give way to 5S and 6S, peaking at U, the highest value Big Ear could print before it ran out of alphanumerics. Astronomer Jerry Amon sees the column and pens one word in the margin: WOW. They searched that patch again and again. Big Ear returned, and other dishes joined the vigil. Nothing. No repeat. The most famous single data point in SETI stood alone, for decades, a footprint with no track leading to or from it. Now, rewind 3I Atlas through space. Fold in its 60 kilometers per second, plot the path backward through the galaxy. In 1977, the object would have been roughly 600 astronomical units away, 90 billion kilometers. To deliver the big ear intensity at that range requires half a gigawatt to 2 gigawatts into a tight beam. That is not a random hiss, not thermal noise, not a cometary burp. Comets do not generate gigawatts. They do not emit coherent narrowband radio at the most culturally obvious frequency in the universe. But a device meant to be noticed could, a single strong pulse, unmissable to anyone listening at the line of hydrogen, and then a deliberate hush. Announce yourself, then coast in quiet, shift to the chemistry. Late August into September, the Very Large Telescope points UVS at 3I Atlas and sees nickel atoms in the gas and hardly any iron. In the natural world, nickel and iron are born together, nuclear twins from supernovae. Nickel 56 decays into iron 56. The elements live in the same grains, weather the same eons. Across our catalogues, meteorites, comets, interstellar Borisov, the Ni-Phi ratio stays within a familiar band. Here, the ratio collapses. Nickel increases steeply on the approach to the Sun, roughly as distance to the -9, while iron remains shy. At these temperatures, the refractory grains that host such metals should not be vaporizing at all. Papers propose exotic reactions in the ice, unusual minerals, dust physics at the edge of our models. Each hypothesis meets the same stubborn wall. The environment is too cold for these pathways. The signature looks uncomfortably like refinement, like iron separated away, nickel left pure. That is an industrial fingerprint on Earth. High-purity nickel for electronics, special alloys, places where iron is a contaminant to be removed, and then the tail that points the wrong way. Solar photons always push dust away from the Sun. That pressure is weak but patient. Over time, it wins. Comet after comet shows the same geometry. The coma around the nucleus, the tail sweeping anti-sunward. Hubble's July image of 3I Atlas, enhanced and measured, shows the scattered light extending farther toward the Sun than sideways or away, roughly twice as far sunward as anti-sunward, with a 10-to-1 stretch compared to the perpendicular. Avi Loeb and Eric Quito offered a model, dayside shedding of large ice fragments that live long enough to build a sunward snowfield, with sizes tuned so radiation pressure cannot easily sweep them back. The maths behaves. The required conditions are knife edge, ejection preferentially from the sun-facing hemisphere, fragment sizes large enough to resist pressure, small enough to scatter visible light, survival times matched precisely to the observed elongation. Possible, just. Like tossing a coin 50 times and getting heads each time. Legal under physics, suspicious under probability. And there's the pattern. For every oddity, one can draft a natural mechanism, but each one asks for a special pleading no other comet has demanded. The mass makes sense if the body is unusually dense. The track makes sense if we accept a rare statistical role. The chemistry makes sense if exotic processes are occurring. The polarization could be waved away, they said, if the dust grains were unlike any catalogue we've built so far. Maybe. Each explanation is plausible in isolation, but we are not dealing with a single quirk in isolation. We are looking at a stack, 7 long-shot anomalies piled on the same traveller. At some point, the simplest story stops being natural and begins to look designed. That is the knot astronomers are quietly worrying at while 3I Atlas slips behind the Sun, just out of sight. And then, as if the sky wanted to underline our limits, October began with a reminder close to home. In the small hours of the 1st of October, 2025, Something rushed through the very altitudes where astronauts sleep. We share that airspace with the International Space Station. We thread it with commercial satellites obedient to their lanes. But this object, catalogued only after the fact as 2025 TF, wasn't tracked at all. We found it about 6 hours after it had already howled past the South Pole, moving at more than 20 kilometers per second. Think about that. A space rock the size of a small car, faster than any bullet, slipping through the same neighborhood where humanity does its most delicate work, and we had no idea it was coming. Later, we would pin down the numbers with the weary calm of a post-event report. Closest approach just after midnight UTC, roughly 419 kilometers above Antarctica, the kind of figure that makes astronauts glance at their own orbital readouts. The Catalina Sky Survey in Arizona finally picked it up at 2:35 Eastern using the Bock telescope at Kitt Peak. But that sighting came 6 hours and 36 minutes after the moment of nearest pass. We didn't see it arriving, we saw it leaving. On the absurd scoreboard of close shaves, 2025 TF now sits second. The record is still held by 2020 VT4, which cut even closer in November 2020. We discovered that one after the fact as well. There's a pattern here, and it isn't comforting. This isn't a tale of incompetence. The people who run our surveys are brilliant and tireless. It's a tale of physics and resources. Little objects in the 1 to 3 meter class are dim and quick and stingy with reflected light. There are millions of them, and they live below the sensitivity we can afford to keep on the whole sky all the time. We've built our early warning net to catch the city killers. 150 meters and up. And it does that job well. The pebbles that can shatter windows in unlucky days, those are almost invisible until they are on the doorstep. Once 2025 TF was in the books, analysts worked backwards to sketch an orbit from a handful of data points. The best fit suggests a stretched ellipse around the Sun with a semi-major axis near 1.62 AU, perihelion around 0.676 AU, aphelion roughly 2.56 AU, period about 2.06 years, a tilt of some 9 degrees to the ecliptic, but the truth is that all of those figures wear heavy error bars. With only a one-day observation arc, the orbit is what we call poorly constrained, condition code 7 on a scale where 0 is crisp and 9 is guesswork. We'll need more nights, more angles, more time. What matters is the lesson. An object passed closer than some satellites, and our understanding of its past and future path is little more than a sketch. It could return in years or decades. It could never come near again. We don't know yet. And while a 2-meter stone would not end a civilization, a hit over a city would be measured in kilotons. Tunguska, 30 to 50 meters, flattened forests across Siberia in 1908. Smaller rocks deliver smaller blasts, but luck is not a plan. If that close pass was a jolt, what Mars delivered was the soft, relentless pull of wonder. For more than a year, a particular rock surface has been quietly keeping scientists awake. Not because of its size or sheen, but because of the story written across it in careful dots. On the 10th of September 2025, NASA announced that the Perseverance rover's evidence for potential biosignatures in a sample from an area nicknamed Sapphire Canyon had cleared the highest bar we have on Earth: peer review and publication in Nature. Acting Administrator Shah Duffy did not hedge. This may be the clearest sign of ancient life we have ever found on Mars. Wind the clock back to the 24th of July 2024. Perseverance drilled into an arrowhead-shaped stone informally called Chayava Falls in Jezero Crater. The instruments lit up. The surface was speckled with what the team began to call leopard spots, light cores ringed by darker halos repeating across the rock like the memory of a once-living mat. The chemistry told its own tale. Minerals such as vivianite, a hydrated iron phosphate often found near decaying organics, and greigite, an iron sulfide associated on Earth with microbial metabolism, appeared together, collocated with organic carbon. That co-location is the crucial part. On our world, microbes love water-rich, low-temperature settings. They consume organics, alter their local chemistry, and leave mineral byproducts right where they lived. Tiny factory, tiny waste pile, tiny circle. The leopard spot pattern looks eerily familiar to geologists who have read similar signatures in ancient terrestrial rocks. Context makes it stronger. Chayava Fall sits at the edge of a formation called Bright Angel, near an ancient river system that once fed Jezero, vast channels that spilled into quieter basins, then back to streams again. Mudstones and layered sediments there speak of cycles of flowing and standing water, the kind of place life loves. Better still, Bright Angel seems younger than the earliest lakebed deposits Perseverance studied. If the pattern holds, it hints that Mars may have stayed habitable longer than we thought, or that life, if it ever took root, survived deeper into the planet's history than our bolder guesses allowed. Caution is the other half of the story. A potential biosignature is not proof. As Deputy Project Scientist Katie Stack Morgan reminded anyone who would listen, claims about life, especially ancient remote life, demand extraordinary evidence. For a full year, external reviewers tried to break the case. Non-biological chemistry, strange crystallization, geological tricks that could paint the same picture. Alternatives remain on the table. None fit as snugly as biology. Two instruments made this possible. Sherlock, the rover's ultraviolet Raman and fluorescence mapper, saw clear spectral fingerprints of organics. Pixel, the X-ray microprobe, mapped elements at the grain scale. Layer those maps and you see organics and redox-sensitive minerals sitting together in the same tiny spots. On Earth, that overlap is a microbial calling card, but the final word probably isn't on Mars. To prove origin, we need to bring the rock to Earth and pull it apart with instruments we cannot yet fit in a rover. That is what Mars Sample Return was meant to do. The plan, joint with ESA, has staggered under cost and schedule. A proposed 2026 budget from President Trump would cancel the current architecture entirely. Duffy floated a pivot to something cheaper and faster. China, meanwhile, has announced its own sample return ambition for around 2028. If the United States does not fetch Perseverance's cash, someone else may, and they may be the ones to settle the question first. For now, the Sapphire Canyon core sits sealed in a tube on the Martian surface, a message in a bottle waiting for a hand to pick it up. Closer to home, another thread tugged at public nerves. On the 9th of September 2025, a House oversight session turned on a video the public had not seen. The footage, dated the 30th of October 2024, shows a bright sphere against dark sea. A Hellfire missile threads into frame, strikes, and, this is the part that knocks breath from rooms, nothing like a normal hit occurs. No flash, no fragmentation. The orb continues on. The missile seems to carry on its own way. That's a Hellfire missile smacking into that UFO and just bouncing right off, Representative Eric Burles said over the clip. And it kept going. Then he asked the question that keeps repeating in corridors. If this is nothing, why the walls? The video came from an MQ-9 Reaper working off Yemen, where American ships and aircraft were busy knocking down threats fired by Houthi militants. That background matters. This was active combat space, sensor-rich with rules of engagement in force. The Department of Defense declined to authenticate or elaborate. Nothing to provide, a spokesperson said. The silence didn't soothe. The hearing offered more than a single clip. Veterans testified under oath about encounters that do not fit neatly into our inventory of known machines. An Air Force crewman described stepping outside for a cigarette at Langley in 2012 and looking up into the hushed triangle of something that hung above him, then shot for airline altitude and left the area faster than his eyes could quite register. He filed a report. ARO, the Pentagon's Office for Such Things, interviewed him in 2023. He says the case was dismissed and worse, he felt the cold wind of retaliation on his clearance and career. The committee chair set the tone plainly. For too long this subject has lived under stigma and silence. This is not only about lights in the sky, it is about national security and transparency. The witnesses were not cranks. They were uniformed professionals with clean records. The footage was not a shaky phone clip. It was military sensor data in a live theatre. AARO maintains it has no verifiable evidence of anything extraterrestrial, that it applies a rigorous, data-first method. Critics reply that too many compelling cases are being solved with explanations that don't feel like matches. The Navy's 2015 Go Fast video was eventually explained as a weather balloon seen at a trick of angles and parallax. Perhaps the Yemen sphere is also a balloon, some suggest, and the missile only seemed to connect because of the camera geometry. Former intelligence official Lou Elizondo pushed back. Hellfires do not bounce. When a kinetic strike hits something solid, there is usually very little left. So we are left between two discomforts. Either an American drone engaged something built with technology far beyond ours, and it shrugged off a direct hit, or there is a mundane answer the government will not share, for reasons we can only guess. Neither is soothing. And this isn't an isolated incident. Reports were piling up long before anyone agreed on what to call them. In just the first half of 2025, the National UFO Reporting Center logged more than 2,000 sightings, more than most years used to see end to end. The Pentagon, too, recorded a steady rise. Over 750 new cases in the 12 months from May 2023 to June 2024. Whatever plays out above us is happening more often, or more of us are learning how to look up and talk about it, or both. While governments wrestle with objects that refuse to fit neatly into the inventories of known aircraft and known tricks of light, something far more predictable, yet no less dramatic, has been unfolding overhead, driven by the star that makes life here possible. In October of last year, solar physicists quietly marked a milestone that should have earned front-page treatment. Our star reached solar maximum, the crest of its 11-year cycle. It sounds academic, a thing for specialists, a temperature taken and filed, but the peak itself isn't a tidy plateau. It's the beginning of a feverish denouement, a phase when the sun doesn't wind down so much as throw confetti and thunder. Think of a firework. The biggest flare of light sweetens near the end. In the same way, the declining side of a solar cycle can deliver more geomagnetic storms and more auroras than the rise. One space weather scientist put it simply, peak auroral activity tends to arrive a few years after the official maximum. In other words, the show isn't over. The encore is only just taking the stage. Under the hood, the choreography is familiar. Sunspots bloom where magnetic fields twist and knot. When those fields snap and reconnect, they fling energy outward as solar flares and coronal mass ejections. CME for short. A single CME can throw billions of tons of plasma into space at speeds well over 1 million miles an hour. If that cloud's aim is true, Earth's magnetic field shivers and funnels charged particles toward the polar skies, where they brush atoms and make curtains of green, rose, and violet. Then comes the twist most people don't hear about. After the numerical peak, when flares and CMEs begin to taper, the The Sun's coronal holes grow large and long-lived, gaps in the corona where magnetic field lines open clean into space. Those holes spit fast solar wind for weeks or months. They don't make a single punch, they keep jabbing. The sustained pressure can rattle our magnetosphere as effectively as a direct CME blow, sometimes more so, and with a rhythm that aurora chasers learn in their bones. We're already seeing it. In early October 2025, Earth rode through 5 straight days of heightened activity, driven by a fast stream from a coronal hole. Solar wind climbed to about 768 kilometers per second before easing down towards 608. Even at the lower speeds, conditions dipped into G1, minor storm territory. Night skies over the northern United States flashed with color. New York got a show more than once. Photographers in Iceland and Norway, Canada, and the Great Lakes region posted frames where the heavens looked like silk in a breeze, and those were just the warm-up acts. An M1.5 class flare early in the month launched a small CME that forecasters expected around the 8th, another nudge on a door that's already ajar. Cycle the 25th of May keep this tempo into 2027 or beyond. Fewer outright flares than the crest, but more frequent storms as coronal holes take their place in the playbill. The calendar helps too. The weeks around the equinox tilt Earth's magnetic field just so, opening a more welcoming geometry between solar wind and our armor. It's a seasonal effect that space weather forecasters treat with the same respect mariners give a prevailing tide. Of course, the light show has a practical side. Geomagnetic storms can hiss static into radio, jostle GPS accuracy, tug satellites down into thicker air, and, on the worst days, ask awkward questions of power grids. In March 1989, a potent storm tripped Quebec into a 9-hour blackout. Transformers overheated, circuit breakers threw up their hands, and millions sat waiting for the grid to remember itself. That was a G5, the top of the scale. This month's activity has mostly ranged from unsettled to G1 or G2, with occasional G3 bites. Nothing like 1989, but enough to make satellite operators tighten straps and airline dispatchers rethink polar routes. The KP index, the familiar 0 to 9 gauge of geomagnetic fuss, spent the first week of October wandering between 3 and 5, peaking into storm range now and again. Forecasts suggest more of the same. Frequent restlessness with spikes. For most of us, it means something simpler. It means to step outside after dusk and look north if you can, or south if you live beneath the southern lights. High latitudes will have regular chances. Mid-latitudes, down toward 40 degrees, can get lucky on the stronger nights. If this kind of calm skykeeping is your thing, you're welcome to curl up with us at Space Historian. Subscribing and tapping like helps keep the lantern lit quietly without breaking the spell. While the sun paints glow across the world's ceilings, other visitors are slipping in from the cold. Something rare is happening this October. On the right evening, from the right place, you could see not 1, not 2, but 3 comets in the same sky, each glowing green, each discovered this year. One might even reach the hazy brink of naked eye visibility, a treat in an era where most comets remain whispers for binoculars. The leader of the trio is C2025A6, better known as Comet Lemon, for the Mountain Observatory in Arizona that first noticed it on the 3rd of January. At discovery, it was a ghost at magnitude 21.5, so faint some initially logged it as an asteroid. Follow-up images revealed a condensed coma and a stubby tail. For months it stayed a specialist's friend. Its name passed between observatories. Early models said it might crest around magnitude 9 near its the 8th of November perihelion. A pleasing binocular quarry, nothing more. Then August changed the script. Fresh from solar conjunction, when it hid in the sun's glare, the comet returned brighter than expected. By the 19th, estimates hovered around magnitude 11. A short, spiky ion tail became obvious. The climb didn't stop. Late September brought the comet to the 8-9 range, easy work for binoculars and small backyard telescopes. Astrophotographers started to catch long blue-white blades of ion tail marked with twists and kinks, places where the solar wind had tugged at it, along with a dust tail growing in confidence. On the 30th of September, some measured it near 6.6, with the ion tail reaching 3 degrees across the sky and dust beginning to show its own fan. If the trend held, the projections nudged it to magnitude 4, maybe even 3, near its the 21st of October, closest Earth approach at a friendly 42 degrees from the Sun, an hour after dusk in the west. Of all the possible geometries, one of the kind ones. Dark sky watchers might glimpse it as a faint fuzzy star without optics. It should brighten further into early November as it drops toward perihelion. Halloween through the second week of November could be the sweet spot, with the path slipping through Ophiuchus for northern observers. It's a once-in-a-lifetime geometry. Lemon's orbit is so stretched it may not return for more than 1,000 years, if ever. The second traveller, C2025 R2, Swan, announced itself at the last second, spotted in images from SOHO's Swan instrument literally a day before perihelion. It hid in the sun's glare until then. Ground telescopes couldn't find it. Swan is already past the sun and won't grow much brighter, but as it separates from the glare, it's growing easier to catch. On the 20th of October, it sweeps past Earth at about 24 million miles. Photographs have already framed its tail drifting near the bright star Spica. This weekend, it will pass within a degree of Mars, a perfect pairing for anyone who likes to sew planets and comets into one field. The third is C2025 K18 Atlas, from the survey whose name says what it does. The Asteroid Terrestrial Impact Last Alert System. Atlas often finds comets while hunting rocks. K18 is fainter for now, but brightening. Pre-dawn hours in the coming weeks should favour it. Binoculars, patience, a steady chair. Why the green? The glow comes from diatomic carbon, 2 carbon atoms bound together, which absorbs sunlight and re-emits at a green wavelength. As comets warm, sunlight breaks larger organic molecules apart and liberates C2 into the coma. The nearer the sun, the more carbon, the greener the sheen. There's even a fourth green visitor, if you count the dimmest among them, the interstellar wanderer many now call 3I Atlas. It shed its earlier crimson blush and turned emerald as it met the inner system's light in ways we're still learning to pass. But that story, stranger and older, is for another turn of the page. For now, it's enough to say Comet Lemon has already outrun expectations, developing nicely. As one observer from the British Astronomical Association put it, worth the early alarm, worth a thermos and a hat. Comets, of course, are weather of a sort. They make liars of forecasts. They fragment without warning. They fizzle right when the schedule said dazzle. Part of their charm is the permission they give us to be wrong in public and delighted anyway. While nature offers its pageant, auroras in silk, comets in jade, industry sharpens its tools. One company is about to light the wick on the largest rocket anyone has ever built, a machine that could shift how we travel or stand as a brave failure in the catalogue of big swings. Circle the 13th of October, 2025. If schedules hold, and with SpaceX they are always sketches, not treaties, the 11th Starship flight will rise from the Texas flats at 6:15 in the evening Central. It is not just another iteration, it is the farewell to version 2. Everything after this grows. Larger tanks, more thrust, a design that carries forward what fire and salt water have taught. This year has not been kind. Flight 7 broke apart during its early burn in January, 4 of 6 upper stage engines quitting, attitude control lost, telemetry ending in a scratch of static. People in Florida, Jamaica, and the Turks and Caicos saw the breakup. Flight 8 in March looked triumphant for a moment. The Super Heavy booster slid back into the arms of the tower in a catch that felt like science fiction. Then the upper stage, Ship 34, lost 4 engines, tumbled, and came apart 9.5 minutes after liftoff. May brought Flight 9 and the first reused Super Heavy booster, a milestone, followed again by an upper stage that couldn't finish its work. 3 losses, 3 investigations, 3 redesigns, a season for patience. Flight 10 in August finally eased the room. The booster splashed down as planned. The ship arced suborbitally as designed, re-entered with its heat shield keeping its promise, made a controlled water landing in the Indian Ocean, and even deployed a set of Starlink simulators along the way, a proof of mechanism for an eventual revenue stream. For the first time in months, supporters allowed themselves to exhale. Flight 11 aims higher in quiet ways. The booster is B-15, a veteran from March's Flight 8, caught and refurbished, now set with 24 flight-proven Raptors. The plan this time is to skip the tower catch and test a landing burn choreography meant for the next generation. 13 engines will light at the start of the return burn, then a transition to 5 during the divert phase, previously handled with 3 to build in redundancy for spontaneous engine shutdowns that have bitten more than once. At the end, the 3 center engines finish the job, easing the booster into a true hover over the Gulf before shutdown and splash. It is a stress test in public view. Success validates the version 3 script. Failure at least happens far from the pad. The upper stage, Ship 38, carries its own list. 8 Starlink simulators, mass and volume twins of the next-gen satellites, will be released on the suborbital arc. They'll burn up on re-entry, but the act of deploying teaches procedures and hardware the muscle memory they'll need. One Raptor will attempt an in-space relight, a must for any mission that requires precise steering beyond a single push. Then comes the heat shield experiment. Engineers have deliberately removed tiles in select zones, some without an ablative layer underneath, to see how plasma finds seams and how much punishment those areas can take before they fail. It is risk by design, a way of learning you cannot capture in a wind tunnel. If Ship 38 survives, it will try a dynamic banking maneuver in the thickening air, a rehearsal for subsonic guidance back to home pads on future flights, then a landing burn and a planned splash in the Indian Ocean. All of this leads to version 3, larger, heavier, more propellant, more payload, more engines on the booster, more thrust at the pad, more lessons welded into the skin, but none of that promise matters if Flight 11 falters horribly. A heat shield burn-through that ends the ship in a bright, brief line will feed the critics who call the approach flawed. A stumble in the booster's new landing sequence will raise fair questions about the choreography itself, and any failure loud enough to echo could complicate SpaceX's relationship with the one partner it cannot afford to disappoint. NASA, which is counting on Starship to deliver astronauts to the lunar surface for Artemis 3 in 2027. The stakes feel like a tightening string. Starship is not merely a vehicle, it is the hinge on which SpaceX's whole promise swings. Cheap routine access to orbit, tankers refilling tankers in space, cargo and crews flung not just to the moon, but onward, all the way to Mars. constellations deployed faster and cheaper than anything we've seen. Grand plans that read like science fiction, until a stainless steel tower survives ascent, does its jobs, and comes home in one piece. Before any of that, though, the explosions have to stop. Flight 11 is the moment to close the book on version 2 with grace and carry momentum into the version 3 age. The window opens on the 13th of October. Millions will be watching. In the hush before ignition, everyone will be thinking the same prayer in different words. Let it fly and let it live. While SpaceX refines a machine the size of a skyscraper, another program, quieter, already far from home, is chasing an object that might solve a riddle parked right next to us. On the 28th of May 2025, just after 1 in the morning local time, a Long March 3B rose from Xichang and carried with it a question wrapped in metal. Is there a shard of our moon masquerading as an asteroid in Earth's neighborhood? The spacecraft is Tianwen-2, the second step in China's planetary line. Tianwen-1 went to Mars and delivered both an orbiter and a rover. Tianwen-3 aims to bring samples back from Mars, an ambition that suddenly looks less hypothetical given NASA's turmoil. Tianwen-4 is charted for the outer planets, but Tianwen-2's quarry is closer, an odd little body formerly known as 2016 HO3, and more familiarly as Kamo'olawewa. Kamo'olawewa is what dynamicists call a quasi-satellite, a companion that really orbits the Sun but hangs near Earth in a long, looping dance that never strays too far. It's small, perhaps 40 to 100 meters across, Ferris wheel scale, and completes a year in almost exactly our time. From here, it looks like it's pacing us. What makes it truly peculiar is its color and spectrum. In 2021, researchers noted how much its light resembled weathered lunar rock. One hypothesis says it is literally a moon boulder thrown free by an ancient impact, a child wandering near its parent. Another says it's a more ordinary asteroid, a refugee that blundered into this resonant track through gravitational footpaths we don't yet fully map. Either way is a story worth telling. The only way to choose between them is to go and bring some of it back. That is the mission. On the 6th of June, a week after launch, China's space agency released a modest update. Healthy telemetry, over 3 million kilometers downrange, a solar panel photographed against the black. It looked routine, quiet, competent, real. The flight plan is patient. A year of cruise, arrival in 2026, then another year circling something tiny and fast. Kamo'olawewa is the smallest body ever targeted by a spacecraft, and it spins once every 28 minutes. Landing on it is less set down and more catch a merry-go-round in the dark. The sampling plan reflects that difficulty. First a hover, match the spin, nibble a little material, then a touch and go, like OSIRIS-REx and Hayabusa 2. Brief kiss, quick jump, finally an anchored attempt, drills in the lander's legs to bite into regolith and hold fast long enough to work. The goal is 100 grams or more. A few spoonfuls doesn't sound like much until you remember you are trying to scoop it from a stone that could hide under a football pitch, 40 million miles from home, with a robot that must act on its own because a radio signal takes too long to ask permission. Samples sealed. Tianwen. 2 heads home. In 2028, it will separate a return capsule that plunges through the atmosphere at 12.1 kilometers per second. Hotter and harder than anything returning from lunar distance, and if all goes well, lands with lunar-looking gravel inside. Then the bus doesn't retire. It uses Earth for a slingshot and sets off again, this time toward 311P/Pan stars, a main belt oddity that blurs the line between asteroid and comet. Orbit, that in the mid-2030s do remote sensing, push the mission life toward a decade. 2 destinations, 1 craft. It's audacious in a way that feels planned rather than showy. The implications ripple outward. This is a direct challenge to the old order. While America argues budgets, trims teams, and delays architectures, China is launching, navigating, sampling, returning. If Tianwen-2 delivers the first Kamoa-Lewa fragments to a clean room, and if later it returns Mars samples while our own program stumbles, it won't just be a technical achievement. It will be a banner planted in public imagination. The race never ended. It simply changed tracks. Right now, Tianwen-2 is millions of kilometers out, riding sunlight and the steady push of engines, headed for a stone most people have never heard of. When it arrives, when the dust is sealed and sent home, people will learn the name quickly. Only 3 clubs have fielded successful deep space sample returns. China aims to make that list read United States, Japan, China, and then add a second entry. All the while, the agency that once put bootprints on another world is enduring a strain that reads like a cautionary tale. At 12:01 a.m. on the 1st of October 2025, the US federal government shut down. Inside hours, 15,000 NASA civil servants received furlough notices and turned off their lights. Labs went still. Offices emptied. Proposals went unanswered. For most of the agency, work simply stopped. Not for everyone. A little over 3,000 were deemed essential and told to report without pay. They have to keep spacecraft alive. International Space Station controllers still send roughly 1,000 commands a day. Tend life support. Watch for emergencies. You cannot furlough the people who keep air in a habitat you share with other nations. So they work on IOUs while Congress trades speeches. Artemis 2 kept its lights on. The Moon program is more than engineering now. It's a statement of intent. In a post before the shutdown, the acting administrator's language was blunt about competition and timelines. Thousands of workers and contractors attached to Artemis 2 and Artemis 3 and their commercial lander partners were told to carry on through the stoppage, log hours, and trust that payments would arrive when the gears turned again. Slipping further behind was framed as a national security cost. None of this began on the 1st of October. Earlier in the year, directives cut NASA's headcount by more than 4,000 through deferred resignations, stretching into January 2026. These are not temporary furloughs, they're exits. Over a fifth of the workforce gone. Hidden inside those statistics is expertise that takes decades to build. Power systems architects, propulsion leads, life support veterans, flight dynamics wizards. One engineer at Johnson spoke anonymously of losing a leading power systems expert, no small thing when you are trying to put a nuclear reactor on the moon. Budgets are the culprits and the cudgels. The proposed request for fiscal 2026 would be, in inflation-adjusted terms, the agency's leanest since 1961, the year Shepard rode Freedom 7. Within that number, a nearly half cut to science. 41 missions slated for the Axe, including some already in flight. That detail stops you. These are not paper studies. They are spacecraft operating, discovering, delivering. Turning them off wastes money already spent and extinguishes streams of data that cannot be recaptured. The names on the list read like a syllabus. The Nancy Grace Roman Space Telescope, built to map dark energy and find exoplanets by the thousands, nearly complete and suddenly under threat. OSIRIS Apex, reshaped from a triumphant asteroid sample returner into a follow-on mission to Apophis, told to stand down mid-journey. Mars sample return, already counting sealed cores on Jazero's floor, told to accept a halt while others sprint. Even stalwarts with long legacies are said to be at risk. Chandra, which has given us a quarter-century of high-energy sky. Hubble, the telescope that taught the world what a spiral arm and a nebula can look like, Earth-observing satellites that keep watch over coasts, forests, and atmospheric rivers. Planetary defense lines being drawn thinner only days after a 2-meter rock skimmed the edge of our occupied space. Inside the agency, some are blunt. You cannot impose an unpassed budget from the top down and call it law. You cannot ignore procedures and the will of Congress and expect people not to notice. But the violations often arrive in memos and calendar blocks out of view. The harm spills past NASA badges. Universities run on grant cycles as much as timetables. Pause payments and labs seize up. Graduate students suddenly find themselves unfunded. Mid-career researchers look for exits because rent doesn't wait for appropriations. One ultraviolet astrophysicist at Johns Hopkins spoke of going hat in hand to his university for emergency support to get a sounding rocket across the finish line. He is, by any measure, one of the lucky ones. Smaller departments do not have reserve cushions. Their projects simply stop. Allies watch warily. Partnerships with ESA and others on Mars sample return and lunar work carry contracts and reputations. If NASA cancels, delays, or redraws missions unilaterally, the strain shows. Trust takes years to build and a quarter hour to lose. The intangible damage may be worst. Space is a long game. You cannot mothball a probe mid-cruise and pick up where you left. You cannot ask Jupiter to keep its moons aligned while you sort out a continuing resolution. Experience is not something you rehire off a shelf. When programs are chopped and restarted, when people walk out with 30 years of tacit knowledge, the loss compounds. Every shuttered mission is a discovery that remains unmade. Every exit erases a mentorship that would have lit a path for someone new. Every shutdown is momentum bled away that must be slowly, painfully rebuilt. There is still resistance. Outside headquarters in Washington, staff and supporters have gathered with signs and speeches, asking for full funding and an end to the death by 1,000 cuts. Members of Congress from both parties, the ones whose districts live and breathe spacecraft, have pushed back, proposing appropriations that climb above the request. As of early October, nothing final has been signed. Those votes will write the next chapters. One fork preserves exploration, rebuilds confidence, and keeps American leadership real in deeds, not just in slogans. The other accepts a managed decline in which we watch as others set the pace. These choices are not being made in clean rooms or control rooms. They're being made by people who may never walk past a thermal vac chamber, but whose signatures can switch off a telescope that takes a decade to build. This is the weather of October 2025. A car-sized rock slips through the lane where our astronauts sleep. Possible fossils glitter on a Martian stone and wait for a ride home. Military footage shows a bright sphere shrugging off a missile and keeps its secrets. The sun hums through its most restive years for a generation. Comets, green as bottle glass, climb into our evening. China executes a plan with tempo and money. A private company builds the mightiest rocket we've ever seen, while the public agency that once led us outward fights to keep the lights on. The universe doesn't notice our budget hearings. It will keep its appointments whether we make ours or not, but it matters that we try. It matters that we keep asking and measuring and learning, because every answer we wrestle from the dark adds to the small, bright pile of human knowing and reminds us we belong to something vast. If keeping vigil over that vastness is your kind of night reading, a quiet subscribe and like for Space Historian helps more than you might guess. And right now, we're in danger of forgetting that truth at the exact moment when we need it most.